Okay, we have a little bit of coordinate geometry here, and basically we're being asked to evaluate graphing a quadratic equation on the coordinate plane, and we are being asked about the 2 points at which this graph would intersect the y-axis, or sorry, the x-axis. And the points at which we intersect the x-axis, which I've labeled over here in green, are the 2 points at which y would be equal to 0, because when you intersect the x-axis, you are neither above or below the origin, and so you are at a point where y is equal to 0, and you're either to the right or to the left on the x-axis, which always was something that confused me a little bit when I learned this growing up, because when you hear x-intercept, it just sounds like x would be equal to 0, but x is typically not equal to 0 at the x-intercept unless you intercept at the origin. So we have 2 points here where y could equal 0, or y does equal 0, and we have some other point for x. So both of these points are going to be something for the x and then a 0 for the y. And if we look at our original quadratic equation, y would equal 0 when x would equal either negative a or negative b, because plugging in a negative a here would wipe out whatever we would get by plugging in a negative a here. Negative a plus b on this side would get wiped out by the 0, which it's multiplying, to give us a 0 for y. And so if we have a negative a or a negative b, it'll wipe out the entire right-hand side of our equation and give us a 0 for the y. So we know that negative a and negative b are the x coordinates of these intercepts, but this is a data sufficiency question, and we are looking for actual hard concrete numbers like 5 or -6. So we need to be able to narrow down our answer choices to 2 specific hard numbers. Let's see if we can do that using statement 1. Statement 1 says a plus b is equal to -1. Well, all this tells me is that a and b are 2 numbers that add up to -1, but they could be really anything. They could be, for example, +2, -3, or +3, -4, +4, -5, and on forever. So there's infinite possibilities based on this statement, and we have no hints about what it would need to be based on the original question stem itself. So I'm going to say this is insufficient. Remember, if you get into a situation where you're getting more than one possibility for answer choices in a data sufficiency question, that typically means that it's insufficient. All right, evaluating statement 2, we find out that the point 0, -6 is the y-intercept for this original formula we had up here, which means when I plug 0 in for x, I get 6 out for y. And so the formula is really just like the recipe for this line. Anytime I plug in an x, I'll get y coordinates out. And in this situation, I'm getting a -6 out, which means that a times b, if I add this up, I get a, add this up, I get b. A times b is equal to -6. But that could be an infinite number of possibilities as well, because I'm not told that a or b have to be integers. It could be -1 and 6. It could be 1 and -6. It could be 2 and 3, -2 and 3. It could be 2 and -3. It could be 36 and -1/6, which also multiplies to give -6. So there's infinite possibilities, and again, that's insufficient. Okay, so we have these 2 statements together, and we know that looking at our answer choices, A, B, and D are out. So we're between a C and an E answer right now. How many numbers are there that add up to -1? So A plus B equals -1, and multiply to give -6. Well, there's actually only one set of numbers for which this will work, even when we consider fractions and integers alike. There's only going to be one combination, and we could solve this through substitution, but this is something that I know from doing quadratic equations. Whenever we have this set up in a quadratic equation, there's always one solution. And I focus typically on looking at the integers that are factors of AB. So that would be, I know it's a mix of a positive and a negative number, and the numbers that multiply to give 6 are 1 and 6 or 2 and 3. And if I look, the numbers that would add up to give a -1 would be +2 and -3. I'm looking for numbers that have a difference in absolute value of 1, and I'm going to make the larger absolute value a negative so that when I add them up, I get a -1 as my answer. So this is the only possibility. These are my two values for A and B. So I basically have x plus 2, x minus 3. And then the actual roots here, or solutions, are -2 and +3, which would set this side equal to 0. Depending on which one I choose, it'll wipe out the other side. And so I know for a fact that those are my roots, and the answer choice here is answer choice C. The statements together create a sufficient answer, but neither of them on their own were sufficient.